my name is Daryl, and this is Programming in Any Language. We are working with C# right now, but the principles are the same in all languages. Master these principles and you can easily jump to any other language quickly. Today we're going to take a look at exception handling. The last time we did our little math operation, everything seemed to be going well. It often does when the program is doing the testing. As programmers, I think we tend to subconsciously know where our programs might fail, so we tend to avoid doing things that will make them crash. It's not such a good idea. We are building our programs for users, and users tend to do to our programs things we didn't expect. Like entering a letter when a program is expecting a number. Take a look. The last time we saw this program, it was working just fine. And it still is, but there are some things I didn't show you last time, which I want to cover now. If I start this program, it comes up very nice, and I can easily do my 2 plus 2 right here by just going there and typing 2 plus 2 and hit the plus button, and we get ourselves a 4. Great, super, works out just great. I can clear it, go back up here. What if I accidentally happen to type in a W and then I hit 2 down here and then hit add? What happens is the program blows up, dies. It didn't like the way that particular data came in because it's expecting a double to pop in here, and when it tried to convert it by parsing it, and putting it into the variable, the double first number, it didn't work. It actually error out. There was nothing to catch this and handle it. Well, we can fix that. Let's go over here and take a look at this. There's something called simple exception handling. An exception, as you just saw, is an error, an unexpected error that happens when the program is running. If an exception is not handled by the program will abruptly halt or crash, die, blow up in smoke. C# and other languages allow you to write code that responds to exceptions. They're called exception handlers. In C# the structure is called a try-catch statement. You have a try block of code, which is the piece you actually want to run, and you have a catch block of code, which runs when something goes wrong with the try block. Let's jump forward a little bit. Got kind of a graphic to show you how this happens. This is the normal path of code. It's going to be shooting from top to bottom down here. It's going to jump in here. It's going to encounter this try. And it's going to do what we just wanted it to do a few minutes ago with our last program. It's going to try to convert that data and parse it into a double. And if it can't, if it fails this thing, it jumps to the catch block and executes whatever is in here. Now, if it does successfully do this, it bypasses the catch block, just continues on like normal. Our 2 plus 2 would be equaling 4. But in this case, if W plus 2 is sitting in there, and we don't catch that W, doesn't convert to a double, this code is going to happen right here. So this is what you would actually use to cover these errors. Here's a little example of this thing. When you throw an exception, you might have the code written like this. You have try block here, which is going to take in this particular program, it takes in miles, gallons, and MPG, and it reads that miles in from a text box, reads gallons from a text box, tries to do the conversion of miles per gallon by dividing miles by gallons, and then put it out to an output label, but something goes wrong here. Something goes wrong, it shoots out a message box saying invalid data was entered and pops out of there. We can do that with our program. Let's give this a try. Here's our little program, and the problem that's causing the error right here is we're reading this actual number in the text box. What we'd like to do is put a try-catch statement in here. I'm going to actually beef this thing up in size a little bit so we can see it a little better. And let's go ahead and block this off. We don't need to see this much anymore, and we don't really need the toolbox at this point in time because we're just going to be working with code. What I'm going to do is I'm going to take this thing, I'm going to create a try-catch in here. So what I'm going to do is I'm going to put a word try, and I'm going to give it a ellipse and pop that in there. I'm then going to take this and hit enter on here, so I've got this block sitting here. It's got a little error in it right now, but that's okay. And I'm going to take this entire thing I've got here, and I'm going to do a Control X on it and then pop it into here. So it's now sitting within the try block. So this is the code I want to try and execute. And then what I want to do underneath this thing is type in the word catch and put in its block of code. And what I'm going to do down here is I'm going to say if something goes wrong up here, I want it to give me a message telling me what's going on. So I'll say message box .show, and I'm going to say invalid entry. And that's all I got to say. And let's take a look and see what happens. I'm going to do a file save in this thing, and I'm going to do a start. Oops, I got a bill there. Let's check this. What this one is. My error routine. Oh, let's try that again. I want to see my bill there. Let's remember error list is where. Right here. It's got an error in, oh, expect a semicolon. Missed a semicolon again. Where did I miss it? Right here. Okay, yeah, right in the message box. You got to put that in. And now we'll try it. Do file save. And run it. Here's our program. It's popping up again. The 2 plus 2 is going to work just fine again. No problems with it. It functions just fine. Do a clear on this thing. And I'm going to do that W and 2 again and see what happens. Hit add. And I get an invalid entry popping in there. Okay, it says. Okay, so I pop in there. Invalid entry. Really? I better correct this. Now, would have been nice to actually clear this stuff out too. So what I would like to do is actually go ahead and exit the program. Hit this message box in here, and then go ahead and say that my txt first number dot text is equal to quote quote, and my txt second number dot text is equal to quote quote, and I'm going to position the user in the first text box. Txt first number dot focus. And end it like this. Now when I encounter that error, the program's going to really be a little bit more efficient for me. Do a save all, do a run. Hit my W and my 2, try to do my add, invalid entry. Oh really? Bang, click off. It goes right up on top of here and position me right there where I can now type in the 2, hit the 2, and then go and proceed forward. So this works very, very well when you're doing that. Now I'd want to do it to all my other routines too, because I don't have them in here. So you want to kind of put this try catch block in your subtract, in your multiply, in your divide, in your modules, and so on down the line to make this thing work. That's how this works. So the try catch statement can prevent our programs from blowing up when the user enters something they weren't supposed to enter. Good thing to have on hand. It's especially useful when we know or can predict what kind of error the user is going to generate. But sometimes we don't know. What can we do then? Well, a slight variation of the try-catch statement can come to the rescue. When we last looked at this program, we could type in garbage in here and garbage in here. And by hitting add, we're going to get this invalid entry type thing, which we defined. We told it that this is the error message you wanted. But what if you don't know what the error is going to be? There's another way of actually doing this try-catch thing that might be a little more efficient for you, a little better for you. Let's take a look. I'm going to go down to the divide piece on this thing. I can multiply this 2 would be fine, but I'll go down here to this divide piece at this point and double click on it. And the same problem is here. We don't have a try-catch in here, so we're going to end up with this parsing, and we're going to get an error if we type in something wrong. So once again, I'm going to do a try. I'll put that right up in here. Try with my braces, and then take these things and pop them right in there. Control X, Control V to pop it in, and it looks good. And I'm going to set up the catch here, but this time I'm going to set the catch slightly differently. I'm going to say catch, and I'm going to say exception EX. And then I'm going to go down here and do my I can do right up on top here. Get my double braces in this. I've got that piece there. And this is where I'm going to put my error message. I'm going to go and steal the same error message I had up before here, except I'm going to, where are they, right here? I've got this thing as we want to clear it after we're done. And I'll pop that into this catch phrase right here. But I'm doing something different with the catch as well. You notice it already is highlighting something different here. It's looking for caption. You got the caption EX here. We want this EX in here. So instead of invalid entry, I'm going to say EX.message. So I'm going to let the system decide what the message is going to be here. So it's an error is going to pop up. We don't know what kind of error it is, and it will be a problem with our input string. But it could be something else. It could be a file not read right. It could be a number going over bounds or array going out of bounds, something of that nature. But this allows, when you don't know what the error is going to be, you can actually set it up this way so you got exception EX and let the system tell you what it's going to be. So let's take a look at this, what happens when we actually do this thing. I'm going to save all. I'm going to start and run it. And the first thing we'll run is the add one. We know how that works. We put in something like this and something like this and say add, and we get invalid entry. Okay, cool. And it clears it off for us. This time we're going to put the same garbage in. We're going to try to do a divide. When we do a divide, it comes out with a system error. Input string was not in the correct format. Might be a little clearer, might not be. We could be more specific with it, but this thing kind of assumed what's going on here. It's not expecting this, so its input string was not in the correct format. So you can let Visual Studio, C# define what the error is that you've just encountered, and then you can go ahead and fix it that way. This is especially good when you might have multiple kinds of errors that can happen in a code block, and instead of programming for all of them, you can program for just an error and let the system tell you what it actually is. You can now go back into this thing, we'll hit OK on it, and it clears it off, and we're ready to do a nice subtraction or an addition or whatever we would like to do here, and bang, it works just fine. That's it. A more complex program would be better to demonstrate when exception EX should be used, but that will become more apparent when we start to do more complex things, like read a file. What can go wrong when you read a file? Could be you can't find the file. Could be the file is corrupted. Could be the file's already open. Could be the file doesn't have the kind of data you were expecting. In those cases, the system-generated message would be most helpful in diagnosing the problem with your program. We're going to work with handling exceptions in the future. In fact, all of our programs going forward will be designed to prevent unexpected problems from crashing our programs. For now, you've got to start. Just to start. What you need to take out of this video is, number one, an understanding of the try-catch statement. And number two, an understanding of the system-generated error message. We're getting close to writing an actual application. We'll do that soon. So we will use this technique in the very near future. See you next time. Thanks for watching. If you get a chance, please subscribe. We'll see you in the next video. Take care, everybody.